welcome to Notes 10-1, Simplifying Rational Expressions. And this is on page 133. I'm going to do the majority of the work on a separate sheet of paper. So it says that we're going to learn to simplify rational expressions and multiply and divide rational expressions. So a rational expression is a ratio meaning a fraction, of two polynomials. And so the first thing that you always want to do is to find any value that makes the denominator 0. So it says math tip off to the side. In a rational expression, you must restrict the denominator so that it will not be equal to 0, right? We cannot divide by 0. And then it says also another math tip is make sure that you use the original rational expression when identifying its restrictions, meaning check for those restrictions first before you do any reducing. And then also you're going to need to know how to factor pretty strongly in this next upcoming unit. And so if you're still having problems with factoring, you're going to need to come see me. Okay, so step 1 is to identify any restrictions on the denominator. So the denominator cannot equal 0. And so that's exactly what you're going to do. You're going to set the denominator equal to 0. So this is step 1, right? X squared minus 4 cannot equal 0. And then you're going to solve for x. So you're going to set the denominator not equal to 0 and then solve for x. All right, this is a quadratic. So I'll remind you that to solve a quadratic, you can either use the quadratic formula or factoring, or here in this case, right, you could also, since the linear term is missing, you could also take the constant term and move it over. But I'm going to go ahead and factor it. So this is a difference of squares. It's x plus 2, x minus 2, and that cannot equal 0. And then I'm going to apply the zero product property. So I factor, and then apply zero product prop, which is where we take each factor and we say it cannot equal 0, and then we solve for x. And so we get, so we get that x cannot equal -2 and x cannot equal 2. All right, these are our restrictions on the denominator. So x can be any other value, but not 2 or -2. All right, to simplify this, what we're going to do is we're going to factor. So step 2 is to factor both the numerator and the denominator. So that's what I'm going to do. I'm going to factor my numerator. I need something that multiplies to -14 and adds to 5. And those two numbers would be 7 and -2. And so I'll factor the numerator by grouping. So I have x squared minus 7x. I'm going to start that again because I messed it up. X squared plus 7x minus 2x, and then minus 14. And I'll take out the GCF of each side. So factor by grouping. That gives me x plus 7, and minus 2, x plus 7. Watch your signs here. And so the numerator factors as x plus 7, x minus 2. And the denominator, we already factored it right here. And so we're just going to rewrite it. It's x plus 2, x minus 2. All right, and then step 3 would be to reduce any common factors. And so what I see is that x minus 2 is a factor of both the denominator and the numerator. And so that tells me that these are going to reduce out. And so my final answer should be in simplified form, x plus 7 over x plus 2. And remember, you cannot cancel with addition and subtraction. And you see that that is what they got right here. There are two restrictions. And then x plus 7, x plus 2. And they note the restrictions at the end. So let's go ahead and note those. Remember, x cannot equal 2 or -2. All right, let's move on to example B. So example B, we have 2x squared plus 7x plus 3 over x squared plus 7x plus 12. Remember, step 1 is to I'm not gonna write the directions each time, but we're gonna go back and read them. The denominator cannot equal 0. So I'm gonna take the denominator and set it equal to 0. Whoops, plus 12 cannot equal 0. And now I have to solve for x. Remember, this is a quadratic, and so to solve this, we're either going to factor or use the quadratic formula. I'm going to try factoring. I need something that multiplies to 12 and adds to 7. My numbers would be 3 and 4, and then I factor by grouping. So I've got x squared plus 3x plus 4x plus 12 cannot equal 0. I'll split it and take out the GCF of each side. The GCF here is x, and I get x plus 3. The GCF here is 4, and I get x plus 3. Remember, this cannot equal 0. And then I will take out the GCF again, which is x plus 3, and group the remainders together. And that tells me that neither of these can equal 0. Now I'm going to apply the zero product property. So x plus 3 cannot equal 0, and x plus 4 cannot equal 0. Again, because we cannot divide by 0, and these are in the denominator. So x cannot equal -3, and x cannot equal -4. All right, our numerator is now factored. We're going to go back, our denominator is now factored. We're going to go back and factor the numerator. So step 2 is to factor the numerator. I'm going to do that right here. So I need something that multiplies to a times c, 6, and adds to b, which is 7, which would be 6 times 1. And then I will factor by grouping. So 2x squared plus 6x plus 1x plus 3. I'll split it and take out the GCF of each side. The GCF here is 2x. That gives me x plus 3. There is nothing in common, so I'll put a placeholder of a 1. That gives me x plus 3. And then I'll take out my x plus 3 and group my 2x plus 1. And that is my numerator. My denominator is right here. It's already been factored. It's x plus 3 over x plus 4. Now, if there's any common factors, I'll reduce those out. So step 3 is right here. I am reducing out any common factors. So I have 2x plus 1 over x plus 4. No need for parentheses. I can actually drop those. So 2x plus 1 over x plus 4. And remember, x cannot equal -3 or -4. All right. At this point, you should try these, right? Try these A, B, C on reducing and simplifying. Again, the steps are never going to change, right? You're going to identify the restrictions on x, meaning set the denominators equal to 0, solve for those values, and then factor the numerator and denominator. Generally, you'll have done the denominator already, so you'll only have to do the numerator, and then divide out common factors. All right, so go ahead and try these. I'm going to pause the video here